Okay, you guys, morning or afternoon. This is your lesson for Tuesday, and it's section 10.3. I know it's going to go in and out of blurry until the camera finally adjusts. We'll try this the best we can. I wanted to post this on here for you guys because, as you all know, the textbook is for both honors and regular, and you all know that your problems are more challenging. So by me showing you the classwork problems, you guys can get an idea of the challenge of them. Also, sometimes it's harder to read the textbook, so I wanted to go on here and explain it. All right, so let's first talk about what you all should know is your area of, again, let the camera just keep readjusting until it can finally pick up my finger in theirs. All right, so you have your notes at home. I do recommend you guys listening to the lesson and writing the notes at the same time. I just think it's really helpful, especially when, if we end up going back to school, you will eventually be assessed on all of this. So with that in mind, you're going to want to have the notes because, as you know, I'm not going to answer your questions without your notes. All right, let's just start. So we all know here is your formula for area of a circle. We know the area of the circle is pi r squared. Obviously, hopefully you all should know that your circumference of a circle is, you can say 2 pi r, or we can say pi d. So those are things to keep in mind. Okay, first two questions, really simple. You guys already know this stuff. So if it wants us to find the circumference of a circle whose area is 49 pi, what I would recommend you guys doing, oh God, this camera, is let's write our formula for circumference. If this adjusts. Doesn't want my hand. So we all know the formula for circumference is 2 pi r, or again, your pi d. So what you're going to want to obviously do is find the length of the radius. We are going to use this area to find the length of the radius. Well, we all know our area formula is pi r squared. All right, great. Well, pi r squared, and you know your area of this circle is 49 pi over 4. So if I cancel out your pi's, you should know that the radius squared is 49 over 4. So therefore, if I just want my radius, you square root, you should get 7 over 2. Yay. So that was pretty easy then. It's just working with the radius and your circumference. Let's substitute 7 over 2 right in for my radius. So your final answer for the circumference would be 7 pi. Eventually this will adjust to my hand and the paper. All right, great. Second question. Find the radius of a circle. So let's just draw it. You guys know I'm visual. So here's the radius. Here's the circle. Here's the radius. Find the radius of this circle, whose area, so this guy's area, so pi r squared for this, is equal to the sum of the areas of two circles. So why don't I just do one thing at a time? So is equal to the sum of the areas of two circles. So the sum of these guys, and the radius, or the radii, are 12 and 16. All right, well, again, this area equals the sum of those areas. This area is 144 pi r squared, plus 256 pi. So that gives me a total of 400 pi. The area of this is equal to the sum of these guys. So that means the area of this circle is 400 pi. So cancel out your pi's. You know r squared is 400. So therefore, you guys know your radius is 200. Okay, pretty simple. Just kind of reviewing and getting adjusted to area. All right, now this is new for you. So for example, it says, what if you want to know the area of a slice of pizza? So think of this as your slice of pizza, your pie. This is the slice. What we do, we call this region, we call this a sector. And just to give you guys a definition, a sector is an area bound bounded by 2 radii and an arc. Okay, so here's your center, radii, arc. So again, this is going to be called your sector. Okay, so pretty simple. Here is your formula, which you guys should be fine with. So we got area of your sector. To find the area of the sector, what we take is your central angle over 360, and you're going to multiply it by, since we said area, you're going to multiply it by the area of the circle. What it is it's a portion of the area. Hopefully that makes sense. This right here is a portion of the circle. So you need to find out the portion of it, and then you multiply it by the total. And that's your formula for area of a sector. Okay, so let's talk about now the problems in which you have. Again, I like you guys drawing your visuals. Do what you would like. First problem. So we have, it says a circular pizza. Okay, here's my pizza. Pretty big, good circle. And the diameter is 12. It's cut into 8 congruent slices. What is the area of one slice to the nearest 10th? All right, so let's create the slice. What they're talking about, so here is your slice. Hopefully you guys agree. Again, understanding when you guys see this, this is what we call the area of a sector. So what I would recommend you guys doing, because it's new for us, is writing down your formula again. I'm going to write CA. CA is your central angle over 360 times pi r squared. All right, well, have a little problem. I don't know my central angle. However, what we do know is I cut into 8 congruent slices. So what we could do is, if we all know there's 360 degrees in my circle, let's take our 360 and divide it by 8. That means each is 45. There you go. You just found your central angle. So you got 45 over 360 times, well, the radius, if your diameter is 12, your radius is 6. So we can do 6 squared, and then you have your pi. It wants the nearest 10th, so your answer is 14.1. That is your area of the sector. Hopefully that makes sense. It's just your formula, central angle over 360 times the area of your circle. All right, let's take a look at question 2. So question 2, I'm telling you the area of the circle is 60 pi. I like, underlining it so you see the information you have. And then I also tell you the area of the sector is 24 pi. So you're not looking for the sector this time. It wants to know what is the measure of the sector's arc. So if you can have your visual, and here's the circle, you guys want to find the measure of the sector's arc. So you're looking for this, the measure of that. All right, so the measure we all know is in degrees, and hopefully you remember the degrees of the arc is the same as your central angle. So and what this question is really asking you guys for is, what is my central angle? All right, let's set up our formula again. So we got our central angle. You can just use it up there, which we do not know. Over 360 times, well, you don't have to do any work because area, this again, if you remember, is the area of a circle, and you already have it. 60 pi. And we actually know it equals the 24 pi. We calculated the area of the sector. And all you're doing is solving this. If you're having problems solving, just so you guys see, first thing you can do is divide by 60 pi. Let's divide by 60 pi. This cancels. Now you have x over 360 equals 0.4. When you cross multiply, you're going to get x to be 144 degrees. And that is your answer. Okay, so those are your first 2 questions. Again, hopefully you're writing this on your paper that I sent you guys, or just writing it on a separate sheet of paper so you have the idea in case you don't want to print it. Let's continue just so you see a bunch of other examples. Okay, number 3. So we want to find the area of the shaded sector. Again, you know this is a sector because this is the radii and there's your arc. The length of the radius is 12 and it says CDB. CDB, this angle right here is 10 degrees. So again, area of a sector. So I'm going to write AS for area of a sector. You guys all know I love abbreviating. Equals, we got central angle over 360. You should keep writing it times pi r squared. Use it as a header. All right, so my central angle. Well, we don't have the central angle, but if you guys recall from circles, this is your inscribed because it's on. So if your inscribed angle is 10, we all should know what the measure of its intercepted arc is. And it is, correct, double. So you get 20. Then, you know, if the arc is 20, remember our central angle has the same measure. So there you go. You found your central angle to be 20. 360 times, well, we got a pi, easy now, 12 squared. For this one, let's leave it in terms of pi. So if you put that all in, if you put that all in your calculator, do all the calculation, you should end up getting 8 pi. And that's the area of that sector. That's it. So you just have to work with the pieces you want to find. I really recommend you guys putting this on your paper. It's a guide for you. All right, let's go to question number 4. All right, so it wants us to find, so now we're talking about the area of the shaded region. So this is also in your lesson. There's only so many problems. You know how to find the area of this sector. It's very repetitive as long as you have all of those values. So now let's talk about the area of a shaded region. So we got shaded region. What I recommend you guys doing when I ask you a shaded region question is, again, give yourself explain to me what you're doing. Explain to yourself what you're doing. So to find this region, well, if I can find the area of the triangle, and the nice thing about this is it's regular, and we all know regular means all equal. So we all know it's an equilateral. So all my sides measure 10. So we're going to find the area, and I like to show that really clear. The area of the triangle minus, all right, well, you should realize that what we have here is sectors, radius, radius, and arc. This is what a sector looks like. So we could say you have sector 1, sector 2, and sector 3. So we have 3 sectors, and they're all the same amount. So let's say minus the area, we'll just put the area, of 3 sectors. And for this problem, I want to say find the, let's include the word exact. So remember, when I say exact, you have no decimals. You leave pi, you leave radicals, anything like that. All right, so let's do this. The area of the triangle. Well, hopefully you remember from 2 lessons ago, your area of an equilateral triangle. Hopefully you got it. Write it down. It's side squared rad 3 over 4. Again, I like to do my thinking. We all know this, right? The formula. So I'm going to do the same thing here. Let's get the thinking out of the way, and then you're just inputting numbers based on what you wrote. We all know the area of a sector is your central angle over 360 times pi r squared. It's just really helpful, especially from learning it. That will find you guys the area of the region. All right, let's put some numbers in here. So we got a side square. Well, sides are 100. 10. I'm change that. 10 squared, rad 3 over 4. 100 divided by 4. We got our 25, and then we'll just trail the rad 3. Done. Area of the triangle. Check. All right, now let's do my 3 sectors. Let's still keep that 3 there. Again, all I'm doing is following it. It's a guide. Really helpful. Central angle. Well, the fact that this triangle is equilateral means all of our angles, we all know, are 60. That's easy for us. So we got 60 over 360 times, if you want to put the pi first, my radius. Well, the length of this is the radius, and it's 5, because this is also 5. So you got 5 squared. when you put all of this in your calculator, so again, since I said the word exact, do 60 over 360 times 25, then times it by 3, and then you trail the pi, and you should get 12.5 pi. So take a minute and try that in your calculator, and that is your answer for number 4. Okay? All right, let's take a look at question number 5. Area again of your shaded region. Pretty simple question. You have something like this for homework. Again, I would write out what you're doing. Talk yourself through the problem. You're going to find the area of half, we can say, the big circle, right? This is half a circle. And then let's say minus, well, let's find the area of half of 1, 2, 3 little circles. So we got the area of 3, half of them, little circles. Again, it's your guide. All right, so here we go. Well, we all know the area of a circle is pi r squared, so there you go. So area of the big circle, pi, the radius, diameter is 12, radius is 6 squared, all over 2, because again, you want half. Let's again, sorry to interrupt, make this the exact. All right, minus. I'm going to trail this 3 on the outside so I don't forget it. Now we want the little circles. And I'm again put it over 2 because I only want half. So if the whole thing is 12 and we have 3 of them, we all know 12 divided by 3. So each one's diameter is 4. So if your diameter of the little guys are 4, you all know the radius, yes, is 2. So we got 2 squared. So obviously you have this, put this in your calculator or do it in your head. 36 over 2 gives you your 18 pi. 4 divided by 2 is 2 times 3 is your 6. And in the end, the area of the shaded region is 12 pi. So double check you have that. Make sure you're okay with that. It's pretty simple. All right, last little topic for today. We want to find this new word. I think one of your questions on your homework has this. So I'm going to draw the picture. And it says the region bounded by an arc and a chord. So we could say here's the arc, here's the chord. What we have here is this region. That region is going to be called a segment. Okay? Well, watch what we're going to do here. Because it's really hard for you to take the area of this circle. I mean, what is this you're subtracting? I am going to create, because this is actually going to help you find it, a sector. So now I've formed my sector, my 2 radii, and my arc, and here you guys have the minor segment. So if you recall, let's remember, we can say a sector, think of it as your slice of pizza. And what we have here is this region that I highlighted in yellow. This is going to be called the minor segment. What I want you to consider the minor segment is the crust of the pizza. Okay? Oops. And then what I want you to do is, I'll just do it in blue, this segment, which is the remaining, that is what we call the major segment, and it's what's left. So this is your major, while the crust is the minor. Okay, so how do you find the area? Well, you have 2 areas as we just discussed. One is called the minor, or I'm going to say again, your crust. So if I ask you guys to find your minor segment, here's what you would do. Hopefully it makes sense. Think about, how can I find this? You're going to find your area of the sector. So you'll find this whole sector. You'll find the whole slice of pizza. But guess what? You only ate this because this is what we want. So then what the heck is the shape of this? This is a triangle. So we're going to take the area of the whole thing and we're going to minus the area of your triangle. Oh, that was pretty bad. But that is how you guys find the area of a minor segment. Still like you guys writing that stuff down. And then the major segment, well, the major segment's pretty simple. It will follow the minor. And if I ask you this, I'll always make it follow the minor. So your major segment, what you're going to do, if you think about it, is this. Well, let's find the area of the whole circle and minus this region, which we call the minor. So we have area of circle minus your area of the minor, running out of room, segment. Again, they will have to follow. The major segment question would have to follow your minor segment. All right, we got 2 examples, and then you guys are done for today's lesson. Hopefully this makes a little bit more sense. Again, these problems are a little bit more challenging than I think what you'll see on for homework, which is why I really want you guys doing it. All right, so it says a regular hexagon, so we all know regular means all the sides are the same, is inscribed in a circle with a diameter of 14. All right, part A. It wants us to find the area of one of the segments. So obviously I couldn't really color it on the computer, so let's pretend I'm coloring it here. That's what I'm asking you guys to find, and it says to the nearest 100th. So again, that would be colored for you. So we understand that this is a minor segment. Okay? So to do that, let's form, we know the minor segment comes from a sector. Because this is going to help us. Let's form the center, and let's create our 2 radii. And then while we're at it, if 14 is our diameter, we all know our radii are 7. Then come up to the top, and let's write, because it's new, in words, how do we find the minor segment? Well, the minor segment, again, is found by finding area of sector minus area of triangle. So first thing, I would write that down. Write in words what you're doing. Then, why don't we write our formulas? Well, area of a sector. Area of a sector is we take our central angle, we put it over 360 times pi r squared. Now, the area of this triangle, I'm going to star. I'm just getting a little ahead of us. Because if you take a look, since we all know here's your triangle, and we all know that this and these are radii, and they are the same. Okay, so if they are the same, then the angles are the same. Well, I got to get ahead again. Let's find the central angle. So here we go. We're going to take our 360 divided by 6, because all of the arcs are the same, and your arcs is equal to the central angle. So you have 6 congruent arcs. We have 360 divided by 6. So 60 degrees is the measure of each arc, which we all should know the measure of each angle is 60 degrees. All right, so now, this is what I wanted to say. If the angle is 60 and these 2 arcs, these 2 lines are equal, it makes these 2 angles equal. So if that's 60, we all should know this is 60, and it makes our life easy. Here we go again. We have an equilateral triangle. So I'm going to write my formula and just write you a note because it's not always going to be an equilateral triangle. All right, now let's start inputting the numbers that we actually have. Okay, so I kind of got ahead, so we know the central angle. Our central angle is 60 over 360 times, we got our pi, we got our radius. You have everything there for yourselves. Minus side again, rad 3 over 4. Now, you can put this whole thing in your calculator. It's kind of hard because it's a lot of numbers. Again, what I would do is maybe put one at a time, but do not round. If you all remember, we talked about this. Do not round your final answer. You should get 25.6563 with other numbers. I'm just writing them down. And then this one is 21.2176 with other numbers. Put it all in the calculator, and to the nearest 100th, we get 4.44. There you go. You found me the area of the minor segment. So just take a look one more time. It's the area of the sector minus the triangle. Just give you a minute to take that in. It should make sense. It's putting all of the pieces together. Part B wants us to find the probability. We're going to say to the nearest 10th. Well, that's kind of easy of this region. You know this. To find the probability I land in that region, you take the probability of the region, so what you wanted region, so the wanted region, and then you just put it over the whole. Well, the wanted region was about 4.44. We're just going to use that. Divide by, well, the area of the whole thing is the circle. So we're going to divide it by 49 pi. Please, if you're doing this, use the parentheses. Otherwise, your calculator is going to do 4.44, divide by 49, and then times it by pi. You want the product, so use parentheses. And when you put that in your calculator, you should get about 2.9% would be the probability. So the probability is 2.9, so not that high. Okay, so stare at that for a moment. And then let's go on. Actually, before we go on to the next question, I know it's not asked, in case some of you guys were wondering, not that you would be, but in case you're curious, how do you find the major? I just want to show you the major. Again, I would only ask you guys the major if I asked you the minor. So what we do for the major is you just take, again, the area of the circle minus the minor. So we have 49 pi minus, we'll just use that for now because I don't feel like putting it back in the calculator. And then if you put that in your calculator, you would get about this. And this is just giving you guys a heads up. I don't want to put that number back in, just in case I asked you for the major. Hopefully that makes sense. All right, let's go on to our last question. So again, I wanted you guys to color in. So I'm going to color this in. Just can't color it on the computer. Okay, so this one is a little harder, which is why I started. You're definitely going to want your calculator. Make sure you're paying attention and following my work because I'm going to have a lot of numbers. Find the area of the shaded region. So again, what we have here, just so you're aware, is 2 minor segments. Okay, so we have the diameter of the circle is 16, and that's kind of what we need to know. And then we'll do the probability. All right, so again, I recommend you guys writing it. I'm just going to write the heading. So to find 2 of them, I want to take the area of the sector minus my triangle. I'm not going to write the formulas. You have the formulas again there, but use this as a guide, and you want 2 of them. Okay, so in doing so, I'm going to form this. And we all know our radius are 8, or radii are 8. So I'm going to trail that 2 there. All right, so here we go. Area of the sector. Well, first we need to know our central angle. All right, so let's take our 360 and let's divide it by 5. So we get 72. So there's your central angle. So we have 72 over 360 times my area, which is 64 pi. Great. I'll worry about that in a moment. Minus the area of the triangle. So here is where it becomes a little harder because in this one, our life was a little easy because if we knew the central angle was 60, the radii are the same, we have an equilateral. In this one, our central angle is 72. So we do not have an equilateral triangle. So for this one, you actually need to do your 1/2 base times your height. So watch why this one's a little bit more challenging. I'm going to take the triangle out so you guys can see it. So we have 72, 8, and 8. All right, so I'm going to form my height here. And here is my base. All right, we know the height forms 90. We know that in an equilateral, in an isosceles, triangle, the altitude bisects it, so it's 36. So ding, 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 the only way for me to find these 2 pieces of information is by me or us doing this, which is why they're a little harder. All right, so I'm going to use the 36. You want to find an angle down there, that's fine, but I'm using 36. We should know that this side is our hypotenuse across from the 90, and this side is adjacent. AH is cosine. So cosine 36 equals hypotenuse, I'm going to write as my height, over oops, sorry. Cosine 36 is opposite, adjacent. Wow. Adjacent over hypotenuse. Again, if I'm going fast, just slow the video down. You can pause it. So you cross multiply. Again, here's the biggest thing. This is not my final answer. So either A, write all the numbers down, or do not clear your calculator, or you might be off. But I found my height. Okay, so now I want to find my base. Well, to find the base, again, what we're doing, we can only work with one of these triangles. So I'm just going to put an X here, and then obviously whatever I find here, I have to double it. So if we're doing that, we now are doing opposite hypotenuse, so sine. So sine of 36 equals opposite over hypotenuse. When you cross multiply, you're going to get x equals 4.7022 something something. But be careful, that's only this. I must times this by 2 to get to my base. So the base is going to give me 9.4045 ... And that's where you guys would get your base and your height. Now, instead of me putting that up here, I'm just going to write base times height over 2. And I'll put a little asterisk, a little star. So here is my height. And here is your base. Okay? Whew. All right. So when you put this in the calculator, again, I'm going to trail that 2. Again, one thing at a time, or put the whole thing in there. If I put this in the calculator, I'm only going to write a few of the digits, but please use your calculator. Minus, if I take this number times this number over 2, you should get about this. And some other numbers. Okay? When you put this in the calculator, you get around 9.77, because don't round it. Take that answer, times it by 2, and your final answer is approximately 19.6. We are rounding to the nearest tenth for this one. That is the area of the region. Again, I told you it was a little bit more challenging. I know we're not done yet, but I know this one was a teeny bit more challenging because the numbers were not very nice. Okay, so please make sure you're okay with following that. And then obviously the last part again is if you're going to find the probability, I'm going to take 19.6, put it over the area, which is 64 pi, in parentheses, and you get approximately 9.7%. Okay, so please make sure you guys understand that. If it goes too fast, give me, pointers, respond, comment. That was your lesson on 10.3 areas of circles, area of the sector. Make sure you know your formula. Make sure you know area of shaded, which I recommend you guys writing your formulas. And then, yes, I agree, this one is the most work, and I believe perhaps the hardest, where you do area of the segment. Again, the segment is the crust. And hopefully you guys got your lesson. All right, enjoy. Bye.